Welcome to Mancinelli's Math Lab. This was a requested video, requested question, whatever. Let's go over it. Kind of a tricky question. We have a loan of 1,000 and we want to pay it back in 20 years. The effective interest rate is 10%. We're given that the first 10 payments are 150% of the interest due. So what the hell is going on there? I think that's probably the most confusing part. I'm just going to call this R1, R2, R3, R10. So the first 10 payments are something. Apparently they're 150% of the interest due. And I don't know what the hell that is. And actually they're not level either, right? Because, well, I'll talk about it in a second. After that, the last 10 payments are X. The last 10 payments are X. And I want to know what is X. And so pretty much, what is X? The story of your life. The story of your life in a math class, we want to know what is X, right? It's all we ever care about is finding X. So how are we going to do that? Well, what I want to do is I want to basically write out a payment schedule, or sometimes called an amortization schedule. I have the payments, I don't know what they are, but then I'm also going to write down the principal repaid as well as the interest repaid. So in year one, let's just do this one step at a time. Year one, what's going on in year one? Well, what is the interest? The interest in year one is equal to the following. So the interest is equal to 1,000. If you think about it, this $1,000 you took out of the loan, it's accumulating for 1 year. It accumulates at 10%. So the interest due is 0.1 times 1,000, which equals 100. Now our payment, which I called R1, remember our payments in the first 10 years are 150% of the interest due. So in other words, 1.5 times the interest due. 150% of the interest due. This is equal to 150. Now, what does that tell you about the principal portion of the first payment? What is P1? This is common notation. This is the principal portion of the first payment. Well, interest was 100, which means we paid $50 of principal. What is the interest portion of the first payment? Well, that of course is 100. So that takes care of the first year. How about year two? Year two, we now are not going to be still having 1,000 times 0.1, but we paid $50. We paid $50 towards the principal, which means the interest in year two is equal to $950. That's how much we owe still, right? Times 0.1, which is equal to 95, which means that the payment in year two is 1.5 times that. 1.5 times 95, which is equal to something. Let's just do it on the calculator. I have the calculator right here. Let's just do it this way. 1.5 times 95 is 142.5. Now, this is our payment, and 95 of it was interest. So minus 95, this will give me the principal portion of the second payment, which is equal to 47.5. And the interest, therefore, in year two, the interest portion of that payment is, what we have is 95, obviously. It's 95, right? All right, let's do one more. In year three, the interest is equal to, now we need to take off 47.5 from 950, because that's how much the principal we paid, right? So 950 minus 47.5 is 902.5 times our interest rate, which is 0.1. All right, that's all well and good. That tells me, well, what is that? Well, obviously, move the decimal place over once. This is 90.25. That will be our interest paid in year three. what is our actual payment in year 3? It's 1.5 times this, times 90.25, which is 135.375. What is the principal portion of the third payment? It's this minus this, so it's minus 90.25, which is 45.125. And the interest portion of this is 90.25. So hopefully you understand what I'm doing. This is common notation, so hopefully this makes sense. And now we need to make an observation. These payments, I just want to look at the principal portion. The principal portion of each payment, it goes 50, 47.5, and then 45.125. Definitely not arithmetic, but I claim that they're geometric. So this is kind of a, you want to find some relationship with the principal portion. So I'm going to do 45.125 divided by 47.5, and that gives me 0.95. So here's the deal. What I'm getting is this. I'm getting P3 divided by P2 is equal to 0.95, and now do P2 divided by P1, and I claim that's also 0.95. The principal portion of the payments form a geometric series, or geometric sequence, I guess you could say. Therefore, I can say the following. P1 is 50, P2 is 50 times 0.95. P3 is 50 times 0.95 squared. So hopefully you're seeing what I'm saying. Let me write down what I just said. Have just said there. Okay, we have this, and you can easily check that this is true, and you can keep going if you like, but what I have now is the following. P1, the principal portion of my first payment, is 50, clearly. P2, though, is equal to 50 times 0.95. P3 is equal to 50 times 0.95 squared. Keep going. Recognize the pattern. Hopefully your pattern recognition skills are pretty good at this point. Go all the way to the principal portion of the 10th payment. What's the principal portion of the 10th payment? Well, according to this pattern, is 50 times 0.95 raised to the 9. Excellent. What I'm going to do is I'm going to evaluate, I'm going to find a equation of value at time 10. Okay, I want to know what x is, right? What is the outstanding balance at time 10? What is the outstanding balance at time 10? Well, it's equal to the loan amount, but now I'm paying all of these portions of principal minus this plus this plus this plus this. Notice I don't need to accumulate any kind of interest, right? I'm only thinking of principal here. So the outstanding principal, aka outstanding balance, is 1,000, and I need to minus the principal paid in year 1, minus the principal paid in year 2, all the way up to minus the principal paid in year 10. Well, we can add those up. We can sum them up, actually. K equals 1 to 10 of 50 times 0.95 to the, let's do k minus 1. This is exactly what it is, and you should be looking at this and saying, that is absolutely a finite geometric sum. For this exam, finite geometric sum is geometric sum in general is your entire life on this exam. Trust me. So now let's just do some algebra, which we're good at, right? So this is equal to 1,000 minus, how do I find the sum of a finite geometric sum? Well, I like to factor out the coefficient here, and I'm left with the following: 1 minus the common ratio raised to the 10 actually, divided by 1 minus the common ratio. And I'll just spare you the details here. You should get 598.7369. So this is, let me just reiterate here, this is the outstanding balance after 10 years. In other words, it's the outstanding balance at t equals 10, right here. Now what is x then? Let's just set up an equation of value to find x. So at t equals 10, we have the following. We have that this 598.7369 is equal to find x, you just do simply a present value, the present value of an annuity immediate. The present value of an annuity immediate where the interest rate is 10. This is calculator work. Actually, let me just write down how to do this in the BA2+. Okay, on the BA2+, these are the steps. On the BA2, going from left to right, we're going to do the following keystrokes. 598.7369. This is actually our present value, so PV. Okay. Then I want to do 10 is N, that's the number of periods I have. Then I'll do 10 is the interest rate per year. The interest rate per year. And I want to compute the payment. Compute the payment. And what you should get is you should get 97.44. All right, so there's your answer. I did it much differently than I actually don't remember what they did. This is what I did. Tell me what you think. Hope this was helpful.